Welcome back to our Azure Cloud series. In today's episode, we will dive into cloud networking basics. It is an essential topic for connecting and securing your cloud resources. We'll cover virtual networks, some of its key components, connection types, and how they all work together to support a modern cloud environment. So let's get started. Let's start with virtual network. Let's answer that big question that what is virtual network or VNet? Well, a virtual network or VNet is a logically isolated network within a cloud provider's environment. Think of it as a private space where your cloud resources like a virtual machine, databases, and application can securely communicate with each other. It allows you to connect your on-premises system to cloud as well, enabling a hybrid cloud environment. That is also possible. Let's break down the key component of VNet. Let's start with subnets. Well, it's in the name, subnet, subdivision of network. But technically, I can say subnets are segments within a VNet that helps organize resources and improve security. For example, you might place web server or your critical application in one subnet while keeping your databases in another subnet, creating a layered architecture with better performance and isolation. So that is where you will use subnets. The next component is IP addressing. It's like just your home address, right? So VNets use private IP addresses to ensure secure communication within the network. Each resource within the VNet receives a unique IP address, enabling seamless communication while keeping traffic isolated from the public internet or public domain. There's one more, that is gateways. Well, gateways act as bridges or gates, allowing communication between different VNets or between on-premises system and the cloud. For example, a VPN gateway enables secure remote access for all your employees or connected data center to your cloud. Now let's look at the benefits of using virtual network. The first one is quite obvious, that is security. VNets or virtual network will isolate resources from the public internet, protecting them from what? With private IPs and protecting it from the threats out there. And network security groups, also known as NSGs. These NSGs allow you to control ingress or egress traffic. You can also call it inbound, outbound traffic, the same thing, ensuring only authorized communication is allowed. Rest, everything will be denied or blocked. Next is scalability. Again, it's a cloud concept, so everything is scalable. Here, cloud networks are also highly scalable, allowing you to add or remove resources as needed without redesigning your entire network. This flexibility is essential for businesses with dynamic workloads. So, if they want to expand, maybe for a short time or long time, it's easy to scale up and scale down. How about cost effectiveness or cost efficiency? Well, you only pay for the resources you consume. That is the mantra of cloud computing. Such as in networking basic, you pay for bandwidth and network interfaces. This usage-based pricing model helps optimizing the cost while maintaining the best performance. Now, let's explore some common use cases for cloud networking. That is your hybrid cloud. But don't worry, I have not missed this. We will learn about types of connections in more detail moving forward. But let's discuss about the use cases first, and then we'll go about the VPN and all that stuff. So the first one is hybrid cloud. Well, many organizations are hybrid these days, and they have a hybrid setup. They extend their on-premises data centers or their offices to the cloud. This allows them to leverage cloud scalability while also maintaining control over mission-critical or sensitive data on-prem. How about multi-tier applications? Well, cloud networks allow, or I will say easily allow, to implement multi-tier architecture where different components, like, for example, a web server or application servers or databases, are isolated in separate subnets. This improves security, performance, and also the scalability. Now we can focus on the connection types, which involves VPNs, peering, and also the connectivity options in the cloud. There are a few more. But let's start with VPN. Stands for Virtual Private Network. A VPN creates a secure encrypted connection between your on-premises network and cloud. This ensures that the data is transferred over public internet, is protected from unauthorized access. There are mainly two types of VPN connection, that is, site-to-site and point-to-site. Site-to-site VPN actually connects your entire on-premises network to the cloud, enabling seamless communication between on-premises servers and cloud resources. For example, a company can use site-to-site VPN to extend its local network into Azure, allowing employees to access cloud-based application as if they were on the local network. The next one is point-to-site. This allows individual devices, such as your employee's laptop, a phone, tablets, to securely connect to your cloud. This is ideal for remote workers who need access to internal systems and applications without being physically present in the office. Now remember, before we move to peering, I told you what VPN means as per the cloud context. But let me add a few more points. When I said site-to-site, well, if you have an Azure network, which is a cloud service of one organization, and then another Azure network of another organization, both are on Azure. Yes, it is possible to still connect those networks with site-to-site VPN. So remember, whenever you think about VPN, don't just stay in this small understanding of, oh, it needs to be on-premises and cloud. No. Any two networks, if they are connected together with the encrypted tunnel, it is site-to-site. How about connecting your AWS network with Azure network? Again, you can use site-to-site VPN concept there. So I hope it is clear. Now let's move to peering. Again, a great feature given by Azure. Well, peering creates a private and a direct connection between two VNets, enabling secure communication between resources in different networks. But unlike a VPN, peering doesn't use a public internet. It used Microsoft network backbone. Yes, Microsoft have their own network channels. Literally, they have cables under the sea. Now, this improves security and performance. For example, you might peer a VNet hosting your web server with another VNet hosting your database, while ensuring low latency communication without exposing data to public domain or public internet. That is how awesome it is. Now let's move to direct connection. That is also known as ExpressRoute circuits. Now, these services actually provide a dedicated high-speed connections between your on-premises data center and the cloud. Now, again, unlike VPNs, which rely on public internet, this direct connect from ExpressRoute use private fiber optic channels given by your ISPs or even Microsoft. So there's a concept called leased lines that is used here. Now, this results in lower latency, high reliability, and improved performance, making them ideal for latency sensitive application and large data transfer. For example, a financial institute like stock markets, like those institutes, might use ExpressRoute to securely transfer large amount of data between its data center and Azure without risking performance issues. So if someone wants best of everything, ExpressRoute is the answer. And you guessed it right, ExpressRoute can get very expensive. Now, private links. There are some concepts called like private and service endpoints. So there is something called private link. As you can see, it's a private connection. So private link also allows you to access cloud services such as databases, storage, and AI tools, or whatever Azure provides, using a private IP address. This ensures that the traffic stays within the cloud provider's network. This enhances the security and it reduces exposure to, again, public internet. Let me give you an example. You can connect an Azure SQL database directly to your VNet without using public endpoints, ensuring that the sensitive data never leave a secure network. This means there is a machine, a server, and a database. They are connected, and the whole communication is happening privately using private IPs. This have nothing to do with public domain. Nothing is going to public domain. That is the best thing possible, especially for your security posture. To summarize, cloud computing enables secure, scalable, and cost-effective communication between cloud resources and also on-premises systems. The key components like subnets, IP addressing, and gateways form the foundation of virtual networks. These are foundational core components, you can say. While connection options like VPN, peering, ExpressRoute, or Direct Connect, or even private links ensure reliable connectivity. By understanding these concepts, you can design a very robust cloud network infrastructure to support your business and become an awesome network engineer. Now, thanks for tuning in to this episode. I will see you in the next one where we will continue exploring more resources or concepts about Azure Cloud. Thank you and take care.